Okay, so you may remember or maybe recall, like when we talked about instructions and everything, other parts of assembly program, we found that we give calls to procedures or functions rather written in C language, correct? Or called from C library. Fine. What if I don't want to make use of it? Like the difference between like if I talk about functions, what happens is whenever we are calling a function, then the control is completely passed to the code which is added in the function. Okay. As we saw that while debugging the code too. And if suppose I don't want, because if I don't want to make use of say functions, what would be the possible reasons? The reason being, as the control is getting passed, stack parameters also do change. The operating system needs to make multiple provisions to support the function call execution. So prior to the what you can call it as permitting these say functions, there was one mechanism that was used by mostly the programming languages to make use of macros. Now what, like if I take say example of, for example, sys2, if I display this function, this executor for you, so you will see that whatever is added as dot something, like you can see some things are there, like for example this, okay, which is part of code, but somewhere you would be seeing this kind of stuff. Correct. So if I see, like for example, let me jump to main. Yeah, so you can see that there is a call for printf and it doesn't specify, like we don't, this is a printf definition probably. This is libc statement. Correct. Moreover, in start, like this is the main part where the execution exactly starts for the code, and it gives call to that libc statement. Libc statement in some sense gives call to, say for example, something here. Like if I see it talks about 1030 EBX10 and so on. So if I go and talk about main, let us see where exactly main is. So it is 11B3. We don't see directly this. If I say pick this, you will be seeing that there is one occurrence of this main. Correct, and this number is not specified anywhere. Fine. And whatever the call that was made here for main, if I go below, okay, it this is only the code added for it. For LP also the code is added. So if you see there is a call, say for example, return for printf, for example, this call to something print, right? And it says it should go to 11FD, and we don't know what exactly this 11FD probably means. Correct. So it would be difficult rather to find out because control is to be passed, the register values are to be preserved, and so on. And there could be possibility of like segmentation fault too while handling the function. So earlier, what assembler used to do, assembler used to support macros, which also was carried forward by languages like C, where they permitted making use of macros so that it would be easy for uh, the programs to get executed without putting more stress on the system. So if I say generate a code, suppose if I take this code, correct, and one can see that there is call to puts function, correct. So if I assemble this code, if I generate its LST file too. So let us see this. Now you will see that there is a call given to puts E8 and we don't know what exactly the 00, where exactly the 00 is. Correct. Right now we don't have any information. So it must be stored somewhere else. We are not sure about that. But definitely the call would be getting executed when whenever that program gets executed. Correct. So if I say remove this GCC-M32 2103.4. If I execute this code, you may see that uh, output was displayed. That means puts function is doing something over here. And while the call was given, puts code was not replaced by it. Only control was passed. So if I try to say execute through the debugger, so this is our code. So let us jump directly to this breakpoint 19. So run display suppose EIP, display ESP, display EVP. Now concentrate on values of all these three. So if I say next instruction, what happened there? This C8, now this became CD, correct? Because there is something called this ESP was significantly changed. Correct. EBP remained same right now. So if I say next instruction, now one may see here the control was completely passed to this puts, which is written in this shared library .so. This shared library is similar to what we have heard about dynamic link libraries. Okay, in Linux terminology, it is called as shared library. Now, if you see control is inside puts, right, and EIP value also got changed. It is inside the puts code, which is in that library, the shared library. When the function gets done, execution is gets done. Let us see when it is coming back to return back to our original stack pointer and base pointer. So if I say step, now when I wrote NI, it was executing every line in that code. But when I said step, it jumped simply to next line. That means it printed this text. And now it came back again to my EIP. So I could have continued this execution, say by writing NI. Let us see how much time it is taking. It is executing complete lines inside that library, each and every line. And subsequently, the instruction pointer, stack pointer also got changed. At some point of time, it would be returning back, probably. OK, so let us see when it gets back. Yeah. So somewhere here, that code got returned this time. And then it is back to now the original position where your code was, the next instruction to be executed. Now, one may identify here what happened was yeah. So suppose this was my code, correct? If I mark it, say with some color, correct, with borders. somewhere here, suppose there is a call. And this was the function where the code got executed. This was the call. So what happened was from here, control was passed to here. So EIP changed and it stores return address of this instruction. And that's what happened. Like when it completed the execution of this, it returned back to this original position. Correct. Now think of this. If I don't want to pass this control, what can I do? So suppose if there is a call given after this line to this. So what will happen is this code would be dumped here and this remaining code would be patched here. So my code size would be increasing. So the number of times this code is getting called, the number of times it would be dumped there. So if you are calling twice, then this would be double than like if I see more five, like again 5 lines would be added here. In this case, like our 5 blocks are added in this case. Correct. So this is what this scenario, whatever we saw, results to a function call. And if I consider this results to a macro call. Now let us try to see what happens really when we say we are working with a macro. So let me write a code. So how exactly you write a macro? So there is a mechanism. So you write percent macro, like in C language, you write hash define. So you give name, my add. Now you are going to write what is the count of parameters. 2. Now you write, suppose you want to take first, you write %1 first argument. So these are macros in assembly are working mostly on a position based parameters, positional parameters. In what position they are, accordingly they would be picked and mapped. Correct. Now if I write add add EAX comma %2. Now what it says, now pick, you already added, you already took first parameter in EAX. Now add second parameter with EX. Now you don't have to write anything called as return. So if I write, I have to change end this macro. So I will write end macro. Correct. Now your code is done. So let me write now my section.text. So I may not be using, say probably what someone may call as. I'm not using for a while any data element in this case. So you can include all data, text, BSS, RO data, all things can be included there while writing this code too. So you simply write, say, my add 10, 20, my add 40, 60. So suppose my instructions are XOR EX, EX. Here I am saying XOR EX, EX, and here I am saying XOR EX, EX. Now, how many lines of code is there right now in text section? There are 5. 1, 2, 3, 4, 5. Correct. Now, whatever you see here is a definition, macro definition. This 4 line consider macro definition. It has a template. Now, assembly syntax or NASM syntax says you have to write a macro like this. %macro, a keyword. Correct. The name of the macro and number of arguments for a macro. Then if you want to refer the argument, so you have to refer them with respect to their position. So in this case, I'm referring them as %1 and %2. Correct. Now if I write, for example, here, okay, let me first execute this code, then I will show you what possibilities are. So this is my definition, macro definition. Now here, this is my macro call. When I wrote my add 10, 20, this is my macro call. Now what happens is when macro call is given, macro call is replaced by the actual definition, and that phase is called as expansion phase. So first of all, definition phase and then expansion phase. So if I try to say assemble this code -f elf 32, DSM, and if I write dash L P dot LST. Let us see P dot LST. Now you will never see, like if you carefully see what happened was this my ad was written, but it was not translated with anything. But this my ad was replaced by original lines like this: move ex comma %1, add ex comma %2. Same case, this my ad 4060, move ex comma %1. Now if I remove this LST, now if I try to see the code generated in the object code, you will not find out any existence of macro at all. Do you see any macro definition here in this object code? Do you see any macro definition in this object code? Yes, no.
No, sir.
So what happened then? The macro call was replaced by the macro definition by making appropriate changes. So for example, I wrote 10 and 20. So 10 and 20 was replaced by, sorry, the %1, %2 were replaced by 10 and 20 written in hex. Same case with the next call, the macro name was replaced, macro call was replaced by the parameters, the arguments that are added, that were added there. Now, how do it happens? So let me show you the expansion phase. So to see an expanded definition, you write here dash E. So this is the output. Now you will never see macro definition here, but you may see that this was first XOR that you had. Then your macro was added. Move ex comma 10, add ex comma 20. Move ex comma 40, add ex comma 60. Right. So each macro call was replaced by its definition. So this is expansion after macro call was executed or replaced. So at the time of call, the call should be replaced by definition by taking appropriate precautions. So let us try to generate an executable. So let me write this. So let me write GCC. Yeah, let me write, because we don't have any print function. GCC -m32 dot o dash g dash f bar. So let us display value of ex because we have used only this register. So breakpoint main. So if I write L, you will see that macro definition there. Correct? If I press enter, macro call is also there. This is the original source code that is shown here when you write L1. So let me start execution, run. So ex comma ex. Now see, it is executing my add because it is showing you the debugging through the code. Now try to see how many times it is showing us the same line number. So first value was picked. It is showing me the same line number, my add 1020. Correct. Now next instruction got executed. Add ex comma 10 20. Correct. And that's why this ex resulted to 30. Now again XOR ex comma ex. I have my add 4060. So ex would be containing 40. Correct. Now it is executing add. Now you might have seen here, it is showing me this line only. It is not showing me the exact code which was replaced for my add in the debugging mode. But actually, at the time of execution, this my add would be replaced by its definition with appropriate changes in the positional parameter or using the values provided in as a positional parameter. So if I write ni again, my value becomes 0. Understood? Any question? So how the macro definition was? It is like this. This is my code. Is that fine? You must have seen that I called a macro 2 times. So ultimately, when I see the expansion using dash E, I can see that the call was replaced by the definition by adding appropriate or by making appropriate changes in the positional using the positional parameter values. So what happens if I use some other parameters? Say for example, if I use this way, move ex comma 10. So, okay, let us take edx comma 10, move edi comma 20, and you write here eax edx na edx and edi. ECX comma ESI. Now let us see this code. Now I am using register names as parameters for my macro. Let me see the execution. Now see what happened. Move edx comma 10, move edi comma 20. So wherever was %1 in macro call was edx and then edi. So you can see the instructions were changed. ECX ESI, ECX ESI. So it is simply find and replace. Find and replace the positional parameter depending upon which macro call you are exactly talking about. So while you are executing a particular macro call for that time instance, try to see what were the positional parameters mentioned and appropriately pick those. Appropriately pick those parameters. Fine? Any question? Hmm? Okay, so this is one of the simplest macro that one can write. Let me try to write, say, for example, using string instructions, macro length. Now here, we don't have any label included in the code, correct? So Emacs. So let us write percent macro. My str length, my string length, correct? So we are not writing code, say, for example, yet. Correct. Okay, and here our data is section dot data. So with this is our input db. This is sample string of which you will be computing length. Correct. And then section dot text main message dp. The length is %d. External printf. Now main. Now what I'm going to do is I'm going to call this. So move ESI, comma input. Okay, and my strlen, comma, sorry, I'm writing ESI, comma ECX, XOR ECX, comma ECX. Correct. So, and then uh, when it comes back, we'll write push ECX, push MHG, call printf, add ESP, comma 8. Now let us write the code. Here we want two arguments. So CMP byte of ESI, comma 0, jump pip 0 to LP. Otherwise, increment ESI, increment ECX, jump to LP1. If I have to compute length along with 0, because if it matches with 0, sorry. Okay, so let us count length in this case. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 28, 29, 30, 31, 32, 33, 34, 35, 36, 7, 8, 9, 40, 1, 2, 3, 4, 5, 6, 7, 8, 9, 50, 1, 2, 3, 4, 5, 6, 7, 8, 9, 60. Okay, so let us see what is the code. So NASM dash app ELF32 GCC can you see 60? Okay, but let us see what happens at the time of expansion. See the code. The macro is gone, probably. It starts with section.data, correct? This is a sample string of which you will be computing length, and there is a message. The length is %d, correct? And then you have these two lines, and then actually your code is copied here, correct? Fine. So let me take now. Let me create an error for you. So let us say I have input 1 dB sample. So 1, 2, 3, 4, 5. So if I see 1, 2, 3, 4, 5, 6, 7, 8. In this case, length is 8. Here I only am mentioning it as input 1. Now let us try to see. Can you see error now? Label LP1 consistently redefined. Now you may see here, like when we executed the translation phase or expansion phase of macro in this case, as macro was called only once, this LP1 was written here, correct? This LP was written here. Now if I call macro twice, what will happen? This code will be copied as it is by making nominal changes in respect of these parameters only. So for example, like we use the same register. So this code would be copied as it is. Only thing would be what? it is going to print, it is going to take a separate string. Separate string, I mean to say, like for ESI, it would be input 1. Correct? Instead of input. Fine. So if I go back to my code, let me see what is there. So my input 1 is passed here. Correct. So if I try to translate, it is giving me error. So how can I avoid that? It says redefined, but we haven't redefined. But when macro was expanded twice, the label was copied as it is. So ultimately what happened was label was taken 2 times. So how can I remove that error? So to remove that error, we have to write this. So here write %% as a prefix. Everywhere, wherever the label is. Now see how the label, multiple definition of labels are taken care of by the macro preprocessor. So if I translate this now there is no error. Now what must have happened here? So let us see how the definition was replaced. Now see, we wrote what? %LP1. We wrote %LP. So what happened? The code was written like this. .@4.LP1. .@4.LP. Now if I go below, .@5.LP1. So if I write here, like if I write say for nm number of symbols in your file, so it should include that change the LP1 values. LP and LP1 values. Can you see that? So now whenever you do see that whenever a macro is used and that macro contains a label, the macro definition has to make some changes from user side. So user is supposed to write %% as a prefix. Otherwise, the user would be given errors like this, depending upon what label names you use and how frequently you are calling the macro. So to avoid those errors, you have to prefix a label in a macro inside a macro definition with %%. What I did was what I did in the source code. You may see I used %%. I used %%. I used %%. I used %%. Correct. So ultimately it is computing the length. So if I now see this code, my object code got generated. Let me assemble this code. Sorry, let me link this code. Let me execute this code. So I can see that length is different depending upon the input string that I have. So what happens if I give one more call to the macro? Okay, now let me do one more change. Now suppose if I use my label here, LP. Now if I don't use this LP1, say for example, suppose if I don't use this LP. And if I'm not calling this macro. Now LP is part of code. LP is part of my label. Correct. Let us see. Now it is giving me error only with respect to LP. Correct. Now what should I do then? Now if I write LP1 there, okay, instead of LP below here. Now let us see whether do you get any error. So you never got an error. It was with respect to LP only because what happened was, so if I see now label my symbols added, you can see LP1 was written into which was macro, part of macro. It is written like this. Whichever is not part of macro was written like this. So both of them are different in some sense. So it is always better to make use of %% sign. Okay, whenever you are dealing with labels inside the macro. Is that fine? Any question? Yes, please. So I'm adding both the codes for your reference. Okay, so that you can use them later and work with the code. Correct? Fine. So now what we did was we were talking about macro preprocessor. And that macro preprocessor was responsible to process the macro before the translation process starts. So that's what the reason why it is called as preprocessor. Fine. Now, while it is pre-processing that, there are two phases. One is macro definition phase, other one is called as macro expansion phase. So my suggestion to you is why not try working with the codes that I added here as a part of trial purpose, like two codes that I added here in chat window. Try them, try to write your own macros, see whether can you write the macro. Similar code only if you are going to refer variables, then our values passed as parameter to the macro, use them as positional parameters, the way that we used %1, %2, so on. If you are using labels inside the macro, always prefix them with % sign. Okay, and it will be helpful for you rather every time to make use of that macro. And you may see that, like say for example, what we'll do is we'll take output of this into the file. Now see the size. Your ASM size contains 493 lines, but after expansion of macro, the macro definition was deleted. Correct, but the macro call was replaced by the definition, and that's the reason why the size got increased. The size of your text file. It is only a text code rather, not an object code. It is not object code yet. If I try to display, suppose the file like this, the macro is not there. So though it is adding few things, like for example, this was added there, this line, this bracket was added there. So these brackets are also consumed over there. And this is where you do see your code got replaced appropriately wherever possible. So some lines are extra added by the system. So what we understood here is whenever a macro preprocessor is supposed to execute, so it makes sure that it will first collect definitions and then replace it with replace call by the definition by making appropriate changes as per positional parameters and as local labels. So like the labels that we used here in macro are called as local labels. They are local to the macro. That's why. So when you are calling a macro with labels, we have to always make sure that every label is prefixed with % sign. Is that fine? Any question, query? Please ask if you have any. If you want to understand again one more time, you can let me know so that I can repeat it one more time. Okay. So I assume you understood this. Can I proceed? So no response directs me to assume that you understood what I tried to tell you. Right. So this is about pre-processing. So in next lecture on Monday, we'll try to see like how at the time of translation, what macro exactly does to process or what the assembler does to process macros added in the source code. Okay. So that is called as pass zero in every translation. So no matter whether you have C code without a macro or assembly code without a macro, always this pass zero would be getting executed. So the assembler which supports macros is called as macro assembler. Is that fine? So Linux internally makes use of a macro called, I think I don't have, but like, okay, let me see if I can. Linux had its own macro called as GNU M4. Internal macro, the way that we saw GNU assembler gas, correct? Or for example, GNU compiler collection GCC. Similarly, there is a macro processor used or defined by GNU in binutils. So you may use this particular reference rather if you want more information about this, though it is not absolutely necessary. But like if you have free time and if you don't have work to do, then better go through this link once. So again, as I'm repeating, it's not absolutely necessary for Systems 2 course. But if at all you wish to get more insights of macros as an OS perspective or as an Linux perspective, then you definitely can go through the link that I added there. Fine. So in Monday's class, we'll basically try to address how can I design my own macro processing phase with assumption that you already started developing the assembler. Okay, whatever, whether it is one pass or two pass, we don't care. Right. So mostly I prefer to have it as a two pass assembler. So before you start processing it through the two pass assembler, this macro assembler would be playing a key role. So that's why pass zero is added, which comprises some more passes internally. Correct. So about them, we'll be discussing in session which we'll conduct on Monday.